All right, so we've made it to the very last new topic, and it's really not new. We just talked about least common multiples. It was the last video, and that was all about just numbers, least common multiples of numbers. We're now going to find least common multiples of algebraic expressions. And you might be thinking, oh dear, that sounds hard. Well, all this means is that we're going to include variables in with our numbers. So I'm going to ask you to, I shouldn't say only, it seems really hard, but what I think you're going to find is that, the variables are actually the easy part. So we're going to find the LCM. I don't know why I wrote it like that. Find the LCM. And we're going to do these three terms, 4x, 6xy, and 8yz. So before you panic, just think, what is a variable and what does it mean? Variables are numbers, right? Variables are numbers. We just don't know which number. But what we do know is that in this problem, if I'm using an x here and an x here, it's the same number. It just doesn't matter which number it is. So go back to what we were just doing with least common multiples. You're not going to be able to do this by listing out the multiples. It's just not really possible. You've got to use the other method that we learned, building it using prime factorizations. So I'm going to list out the prime factorization of 4x. Well, if we did a little factor tree of 4, it would be 2 times 2, right? Which would be 2 to the second. So 4x would be 2 to the second times x. We're good with that. 6xy, what's happening? We've got the number 6. We're multiplying it by 2 other numbers, x and y. We just don't know what they are. I can do a prime factorization factor tree with 6, and it's going to give me 2 times 3 times x, some other number, times y, some other number. Just don't know what it is. And then we have 8. 8, if I do a factor tree, this one I want you to get familiar with, it turns out to be 2 times 2 times 2, 2 to the third power. And then we have times y, right? Whatever number this is the same number. And then times z. Okay. So, if you think back to what we just did, we looked at all of these numbers, right? All the numbers that are in the box, all the different bases, right? Those main factors, all the numbers that appear as bases here. And we had to use the highest power of each one. So let's go through and find those. We've got a 2 here, a 2 here, and a 2 here. Which is the highest power of 2? This one, 2 to the third. So I need a 2 to the third in my least common multiple. What else do we have? We have a 3, and we only have one 3. So our least common multiple has to have a 3. I hope that makes sense to you. Because 6 is in the numbers that we're looking for, the number that's going to be a least common multiple has to be a multiple of 6. And every multiple of 6 has a factor of 3. So our least common multiple has to have a factor of 3 in it. It has to be a factor of 3. Okay. So we're done with the 2's and the 3's. Well, what about these letters? We've got an x here and an x here. X is just a number. We just don't know what it is. It doesn't matter that we don't know what it is, but it has to be in our least common multiple. Because they're exactly the same, they're both to the first power, I just need one of them. I don't need to include it twice. I just need to include it once. So I'm going to put times x. It didn't matter which one I boxed in. Then we have y's. We have a y here and a y here. Well, again, they're the same, so I just pick one. And I include a y in my least common multiple. And then we see that there's a z here. Well, because there's 1, we need to have a z in our least common multiple. Those are all the factors. Now we take them and we cram them together. We simplify it. We do 2 to the third, which is 8, times 3, times x, times y, times z. And if we neaten that up, it turns into 24 x, y, z. This is our least common multiple. This term here, 24xyz, is divisible by 4x, it's divisible by 6xy, and it's divisible by 8yz. No matter what x, y, and z are, this number, right, if I gave you any numbers for x, y, z, remember we worked on evaluating things. If I gave you actual numbers for x, y, and z, and you substituted them into each of these terms over here, and their least common multiple, this number, whatever it would be divisible by all 3 of these. It would be a multiple, the smallest common multiple, for all 3 of these numbers. Okay? All right. Let's do one more of those. Let's do 24 a squared b. So I'm using different variables besides x and y. You can use any letters you want. They just represent a number. And 54 a b to the third. So pause the video and try to do this yourself. I'm going to keep going. So I'm going to do 24 factor tree. 4 times 6, 2 times 2, 2 times 3. Those are my prime numbers right there. 2, 2, 2, and 3. So I'm going to write 24 a squared b as 2 to the third, because I had 1, 2, 3, times 3. And then times a squared times b. And then let's do 54. 54, you might do 6 times 9, 2 times 3, and 3 times 3. So 54 ab cubed, a and times b to the third, is equal to, here's one other thing I just want to make a side note. When we have multiple variables, when we have multiple variables and an exponent, remember the exponent only applies to what's directly beneath it. This 3 only applies to the b. It is a times b cubed. This variable b gets the 3, but the a does not. A has an exponent of 1. There's 1a and 3 b's all multiplied together. That's an important distinction. Getting back to this, we have 2, because we added 2, and 3 3's, 1, 2, 3. So times 3 to the third times, and we just write these, a times b squared. We did not have to do a single thing in either of these problems with the variables. We left them exactly how they were. Now we look at our bases, we look at our prime factorizations. Only this part of the problem matters anymore. And we pick the highest power of each factor. We have 2's, we have 3's, we have a's, and we have b's. Highest power of 2 is this. Highest power of 3 is this. The biggest exponent on an a is a 2, so we pick that one. And the biggest exponent, I wrote it wrong, I'm sorry. This should be a 3 right there, sorry. B cubed. And the biggest exponent on the b is cubed. Those things that I just boxed in green there, those make up our least common multiple. 2 to the third times 3 to the third times a to the second times b to the third, right? These 4 things right there make up our least common multiple. Now we simplify it. 2 to the third is 8 times 3 to the third is 27 times a to the second times b to the third. Now we multiply 8 times 27. Might want your calculator for that. Maybe not. Whoops. Calculator. 8 times 27 equals 216. 216 a squared b cubed. That term, that mathematical expression right there, is the least common multiple for these two individual terms. These things both fit in nicely to 216a squared b cubed. So, what do you take with you? You don't have to do anything with the variables. You just take the highest exponent on each one. It's actually the numbers that cause you to work in these.